G'day folks, it's DIY Guy 123 here. Today we're going to be talking about how to resurrect a 4-post hoist. This is a 4-post 12,000 pound rotary hoist. It's an alignment hoist, which means that it came with plates that fit over the ramps, allowing you to move the back wheels back and forth, and turntables for the front wheels so that you can rotate the front wheels easy. This hoist is 10 or 12 years old. It was used in a commercial shop, automotive shop, and it was taken out of service. It was still inspected. In fact, the inspection had not expired, but the owner noticed that underneath the stainless steel plates for the rear wheels, the ramp had corroded enough that he didn't want to use it anymore because he figured it wouldn't pass inspection, so he wanted to get a new one while he had an opportunity in its downtime. So I bought it from him, and this is an open front style hoist, which is one of the nicer styles. And I just want to show you what kind of corrosion we were looking at here. So there's an actual hole right through the deck. And this ramp is in better condition than the other side. Now, I do want to point out the only corrosion appears to be from where that stainless steel plate started and stopped. The rest of the ramp looks good. It's still got paint on the sides, and nowhere else on the rest of the ramp does there appear to be any corrosion. The posts look very good. They're not likely to corrode anyway because they're vertical. Down near the base, there is some surface rust, but we're talking about pretty thick steel, and that's very minor. And the thing that really tipped the balance for me buying this hoist and investing in the effort in resurrecting it, it came with 2 rolling jacks. So they're both functional. And in addition, the cables had been replaced not long ago to fix this. Now I plan to fix it and install it in the back of my garage so that I can use it for seasonal storage of a boat. I've got a 14-foot ceiling, so keep the boat way up in the air. And I've got a tractor, the front end loader, and I'll be able to put the tractor not all the way under it, but the front end loader will go right underneath the boat and the hoist when the hoist is up. I went over the ramp that I just showed you in detail with this needle scaler. This is a pretty awesome tool, air powered, and it just rattles the rust shale away. We're now hitting it with a belt sander, not because it probably needs to, but we're going to repaint it. We want it to look as good as we can. I've inspected the tracks where the rolling jacks go. They look in good shape. Really, it's just the top deck. And so I'm going to put a skim coat over the top deck of new metal. And on this outside, I'm going to do another coat as well. I don't suspect it needs it, but when you think of the failure, the folding part of the ramp, or the folding risk, is prevented by the rigidity of the sides. And so because of that, I'm going to put a new deck on the top so that a wheel doesn't run through or fall through that. But I also want to do some new metal on this side. On the inside, I'm not going to do it there because it'll interfere with the track, but I may put a piece of angle iron underneath on the inside. I've bought metal from a scrapyard. I found these sheets, and I don't know how thick it is, but it's the same as the hoist. I bought it at 20 cents a pound, so I bought this sheet, that sheet, that sheet. I suspect each of these sheets weighs about 400 pounds. Doesn't look like it should, but they're really heavy. So we've got a straight edge here. We're going to clamp the straight edge down at the right width that we want to cut, plus a ½ inch. And then I'm going to run a piece off with my plasma cutter, and that's how I'm going to cut out the long strips. And so we cut a plate out for the top here. A little bit of a jagged edge along our unsteady hand for plasma cutting, but that's okay. We'll grind it smooth. Basically, that's how this is going to go. Drop a plate right on the top, and we'll cut one out for the sides. And so I'll weld the top along here, along there, and a little bit along the edges, like to the old metal. And then I'll put the new piece of metal on here and weld the new piece of metal on the side to the new piece on the top. So what we've got here is what we've got here is some holes we're cutting in the deck of the ramp, so that 2 reasons. One is when we put our new metal over top of it, there's some opportunity for any condensation that gets between the 2 plates to evaporate. So that's what those holes are for. And the second reason is if we get the top plate on, the new top plate, and we flip it over, I could actually weld on the inside of this, weld this piece of metal to the bottom of my new top plate. It's not really required, but I may do it. And the only way to do that really well is to have your holes pre-cut before you actually put your new piece on. So that's what we're doing. And the other detail I'll tell you is when you're using a plasma cutter to cut a hole in a piece of steel that has no hole to start with, you have to mark where you want to cut your hole, and then start your pilot arc with your torch, and then rotate your torch up vertical like that until it pierces through. And you'll know when you're doing it how fast you can rotate up, because if you rotate up too quickly, you'll get sparks in the face. And if you rotate up at the right speed, all the sparks will go away from you, and then you'll have your hole. So now that the hole is there, we have our template, and we'll just use that to make our round hole. All right. Now, a couple things we did here. I did not just do a continuous line all the way across, because you could overheat the metal in certain spots and warp it. So what I did is I did a couple inches here, did a couple inches here, did a couple inches there. And then I went back and did a couple inches here, a couple inches there, and a couple inches at the end. So I did it in stages, and now I've got my weld going all the way across, and at no time did I overheat the metal. The risk is if you overheat it, it'll warp. So I've used the stick welder. There are benefits of using a stick welder. For heavy metal, it'll penetrate better. This is fairly thick metal. I could have used my wire feed MIG welder, but for heavier stuff like this, I like to use a stick. And I'm waiting for this to fully cool, and after I do, that slag should just chip right off of there. Right. So see how that comes off in big flakes like that? This probably, I don't claim to be a great welder, but this probably would be the best welding I've ever done, just because it's flat and long and heavy pieces of metal. I've seen really good welders, and they're really good welders after they lay a bead like that and it cools. This stuff almost flakes off by itself. If your bead is very, very consistent and very smooth, the flux will come off by itself. Anyway, I want to clean all that off. I'll use a brush, a chipper hammer to clean that off, and then that surface will be done. Okay, so I've got a chipping hammer here. So you'd want to clean it off at least that well if you're going to paint it. And always wear safety glasses when you chip this off. That stuff is still hot. And my father one time chipped that off without any glasses on. He got a hot piece of that right in the corner of his eye, and it was pretty serious. I've done quite a bit of work on these. This particular one, that's a new plate, and I've welded it various spots. You don't need a continuous seam along there, so probably I did it more often than I needed to, but it's a good idea to check these. These are the tracks that the rolling jacks fit in, but this is a protector to keep dirt from going into that jack. So you want to clean out under there, make sure all the dirt's out of there. This protecting guide, or whatever you want to call it, the weld had broken free, so I kind of tacked that back on. And these ramps weigh probably near 1,000 pounds a piece. And this one's even heavier because it's got that great big hydraulic piston in it. They're difficult to move. I've been moving them on those casters right there, but they're still difficult to move. So this overhead crane on a rolling beam certainly makes this much better. I was able to stand it up and manipulate it a bit. Now I'm able to weld at the right, at the comfortable angle. I'm not really good at welding on the side or upside down, or I need all the help I can get, I guess. On the outside of the ramps, right here, under there, I'm going to put a plate on, and there's a plate there, but I didn't want to put a plate on this side because if I did, I'd have to cut that off and then maybe reposition this track, which is, I don't want to get into all that. So instead of strengthening on the outside, I'm actually going to strengthen it on the inside. 12-foot C-channel, 12-foot long C-channel that's 5 inches high. Well, my C-channel is delivered, and it slid right in here, right in here. I tried to slide in there first, and there wasn't enough clearance with that, so I moved the C-channel over here, and it slid right in place. You can see how I'm gonna fasten it there. I've scored along here and scored along there, so I'll take the grinder and clean the paint off those areas, and then I'll weld it, not a continuous seam, but like I always do, tack it here, there, and everywhere. and that's gonna cause this inner, these are the insides of the ramp. So the rolling jacks ride on this track, and that's where the C channel is. I mean, it's way heavier than we need, but I happen to have it. So a couple things that I noticed is these cut marks in the plate, and I initially thought that they were put there from the person that removed the hoist. Maybe they used a torch to cut the bolts off, the anchor bolts, but now I see them in places that are nothing to do with bolt holes. They were actually corroded over and filled up with dirt and so on, just like this. So I didn't realize even what they were, but I now guess they're so that you can run a string line at an angle, you know, maybe line up these bolt holes with the ones from the smaller posts or something. I'm not sure why they're there. If you know, you can point out why these little grooves are cut here in the comments. That would be helpful. But anyway, maybe it says in the instructions, I don't know. Here's the lock mechanism. I'll show you how it works here. Oh, I need two hands. Anyway, basically, when this mechanism right here is drawn forward, that allows this safety lock to move in. It can be done a couple ways. There are airlocks here, or one airlock controlled by two air lines. And there's also this pulley right here that the cable comes down and pushes on that pulley out like this. Now, if the cable ever breaks, this lock will engage. And if the airlocks aren't releasing it, a spring will cause it to engage. So it's kind of like double, triple safety mechanism there. So just want to share that with you. The previous owner, when they disassembled it, instead of pulling out a pin and removing the cable and then pulling a pin and removing a pulley and then removing the cable and then putting the pulley back and putting the pin back in, which would have been really nice, they took all the loose parts and threw them in a bin. Now, I know that it saved maybe 5 or 6 minutes for the entire disassembly to put these things in here, although maybe not, because they would have had to carry these things to a bin. And now I have to sort out which pulleys went in which place. I'm sure the instructions will tell me, but wouldn't it have been nice to have these things put back in the place that they come out of? Just a word of recommendation for anybody disassembling a hoist. Take care when you disassemble it, because someone's going to put it back together. So if you, maybe you don't care, but if you do care about them, then put things back when you're disassembling. Always put things back where they came out of, just for easy reassembly. I was looking at this hoist thinking, is there anywhere else I should check before I, you know, just paint over it and away we go. So underneath this ramp is where the cylinder is. And the cylinder is fixed at this end, and that's the end that hooks to the cables, and the piston goes in and out underneath there. So since it was fixed at this end, I thought, I bet you there's stress on the bracket that it's fixed. Now this thing's upside or right side up, so you can't really see where. When I got the bolts off, of course, there was all kinds of rust under this. I cleaned that out. You can see this is pretty, you know, there's pitting here for sure. There's lots of metal thickness left. I'm not worried about it, you know, breaking free or anything like that, like breaking through, but certainly it shows you what it is. There was never, ever, ever any wear in this. This plate protected that area from wear for its entire life. Yet if you look at this, the pitting is deeper than in other places in the hoist that had tires driving over it every day. So what does that mean? That means metal will corrode faster than it will wear when tires are driving over it. Corrode in an area that doesn't have constant like stuff cleaning the corrosion and salt and so on, water away. But if you look here, there is a small crack, and I've already welded it from the back side, and I'm going to just touch it up on the top side as well. It's probably not a big deal. There's a crack here, but maybe I'll show you at a later part of the video. Underneath, there's a huge, heavy bar that runs along the bottom of this, and the piston grips onto a plate that grips onto that heavy bar, and then on the other end of the plate is the surface. So even if this totally failed, which I wouldn't want that to happen, but even if it did, it's not like the piston is going to come free. It's got an enormous bar underneath that's still holding it. Just the same, there has been stress here to cause that crack, so I'm going to weld that crack up. So I've wiped them down, got the heavy grease off, and I'll go down another round with a cleaner rag and clean them up. I mean, it's a good idea to clean the old grease off because there's probably a lot of dirt that's collected in the old grease. And so you want to get all that dirt out of there. It's not that the old grease is bad, but you want the dirt out of there for sure. And also, when the parts are clean, then you can inspect. You can inspect for cracks and wear and things like that. The main thing that I'm looking for is on the pulleys to see if they're okay, because I think one of these must have been dropped or something hit it, and it had like a in just ever so slightly, and that will wear on the cable prematurely. So I'm going to clean all these, inspect them, and either file off that burr so it's not wearing on the cable. All the bushings and pins have been cleaned. I did this by hand using Varsol on a rag. It was pretty labor intensive. I got to tell you, I probably spent an hour and a half the first night wiping the heavy grease off of these things. I did it in phases. Otherwise, you're going through rags like crazy. So I'd fully saturate a rag before I'd pitch it. And a little tip on oily rags: don't throw them in the bottom of your garbage can, because they can apparently get warm and, like, due to, I don't know, decomposition and chemical reactions and so on, they can get warm and self-combust. Theoretically, it's possible. I think, you know, it does happen with garden mulch. I don't know. Anyway, if you keep your rags around the perimeter of your garbage can until garbage day, they very likely won't have any opportunity to get warm. They'll just, not a mark on them. Others look like it had been heated somehow. There's a small bit of warping, so somebody torched something nearby. But that is not enough. I don't know if you can see the profile, but that right there along this top edge is not enough to warrant replacement. In my mind, it's barely, maybe the thickness of 2 sheets of paper, the deviation there. So they all look good. What's more important though is if you put it on the pin and you kind of rock it side to side like that, and if the play is excessive, then the bushing is worn out. It's not likely the pin is worn, but the bushing is worn out. Now, I guess, unfortunately, since I have nothing to compare it to, I can't tell you whether that's excessive or not. Someone who knows this business might be able to tell you right off, hey, that bushing's worn out. There's definitely wear there. I doubt it came like that from the factory, but I'm not overly concerned about that little bit of play. And so this bushing right here, all it does is keep the pulley centered on the pin. It prevents the pulley from going down or up on the pin. So the fact that there's play like this, I really don't think makes a bit of difference. But again, I'm not a professional. While you're looking at your pins, like some of these pins, this pin looks like absolutely brand new on this surface. Over here, you can see there's minimal wear. Really all that is the finish is tarnished. I've had my glove off and I cannot feel anything. Even though I can see something there, I cannot feel anything. I will show you this though. This is the pin that goes through the 4 pulleys stacked together. And it is like brand new on one side, but you can obviously tell the side that's opposite to, the side of the pin that takes all the force. And there is some minor wear right here. I can feel it with my fingernail. What's interesting is it's only on this top, where the top of the 4 pulleys would ride. The rest of them are all perfect shape. So what I'm gonna do is, since this pin is identical in length to 2 other pins, and the 2 other pins, the pulley rides in the middle, and in this pin in my hand, the worn one, it's not worn in the middle. I'm simply gonna swap them out. So it's like I've got brand new pins in every location by just paying attention and you know, putting your mind at work to try to reuse parts that are partially worn, to put the worn areas in a position that's not actually contacted when you reassemble. So that's exactly what I'm going to do here, and that way I'll be able to just extend the life of all of these parts. What I'm going to do next is take the cables and wash all the old grease off of them. Now this is a pretty extreme measure. It would be pretty hard to do that by hand with a rag. You could definitely do it. But I think with a rag, you're going to kind of just force the debris that's in the grease. You'll kind of force it to stay along the grooves of the cable. So ultimately, you'd want a running fluid over that to rinse out those particles. And so I've bought a solvent for my parts washer, and that's how I'm going to do it. I'm going to leave the cables all wound up, though, when I do it. I'm not going to unwind them because it just would be too difficult to manage them unwound. So the stack of 4 sheaves are supposed to be separated by these little bushings, and there really isn't much to them. I don't know what they're made of, neoprene or not that even, I don't know, maybe just some kind of a PVC. If you look at the orientation of the cables on the sheaves, the two middle sheaves spin together in the same direction. So that means the bushing that goes between the two middle ones doesn't actually do anything except be a spacer. So there'll never be any friction between those two pulleys. Now, between the top pulley and the next one down, or the bottom pulley and the next one up, they spin in opposite directions. So for those pulleys, or sheaves, I'm going to make sure I put a very healthy bushing in between the ones that spin in opposite directions. For the ones that spin in the same direction, I've got this broken one. Really, it's just a spacer, and frankly, if the spacer evaporated, it's not anything catastrophic. It just keeps the pulleys or the sheaves separated a little bit. I'll probably reuse that one. And this one has a bit of wear on this edge, but it's still thick, so that's fine. But I'm missing one. It didn't come with one at all. In fact, I'll probably replace this one too, I guess. But what I've got here is a PVC cap for, or maybe it's ABS. It's a cap for plumbing piping. And I'm just going to cut it out with a grinder. And the outer diameter really doesn't matter. It's the only, because if it sticks out further than the original, so that's fine. It's not going to interfere with the pulleys. The inner diameter you want to be fairly precise so that it doesn't wiggle around too much on the sheave shaft. So anyway, I'm going to cut that out and make another spacer out of this. Any kind of thick plastic, I looked at like plastic buckets and so on. They're kind of not really thick enough. You could do it, you just have to stack a couple of them. So anyway, that's how I'm going to make one of these spacers. And now that I'm talking about it, I guess I'll replace that broken one too. Okay, I got a quick update for you here. So I put the cables in this tray, and then I dumped a liter of 80-90 gear oil on it. You don't need synthetic oil for this, just regular gear oil is fine. And of course the cables were already bound in a circle, so I just kind of rotated them through the oil, you know, over and over again. And I've also got a paintbrush or a wash brush, and I just dip it in the oil and then brush it on, dip it in the oil and brush it on. And these cables have consumed, well, I've spilled a little bit, but not a lot. They've consumed darn near a liter of gear oil. So basically I've saturated them and then let it soak in, and gravity causes it to drain off a lot of it. But what I'll do is I'll kind of squish the bundle like this and squish the bundle like this so it's not round. I'll make it oval, and it just flexes all the fibers and allows the oil to migrate. I suspect this is ultimately I'd let it soak in a bath of oil so that the oil penetrates every fiber. I suspect it will migrate around when the cables are in use, and this is not the last time I'm going to lubricate them, so I think that's okay. I do want to show you something interesting. I swept up after the project was done, and this box weighs about 40 pounds, and this is all the corroded metal and paint, and I call it shale rust, like when it flakes off in a big chunk, and the residue from when I was using the plasma cutter to cut out the new plates. So there's about 40 pounds here of just rusty corrosion, and so I thought that was interesting. If you're curious, I added about 300 pounds of new steel to it, so I think overall there's more there now than there was before.